Welcome to Adopting Zero Trust, an independent podcast that dives into the world of zero trust and tells the story of people who are adopting it. Throughout our series, we'll investigate why zero trust is becoming a critical concept for cybersecurity. Our hosts, Elliot Volkman and Neil Dennis, will have transparent and open conversations with the people driving modern security approaches forward, while leaving vendor hype behind. It's time to remove implicit trust and buzzwords and get to the root of the movement.
Hello, and thank you for joining us today. Today, we have a fantastic guest, Mr. Ryan. Actually, you know what? I'm terrible with giving introductions based on our guest. I would just actually love if you can give us a little bit of background, and then we'll go into the spiel from there.
Yeah, so my name is Ryan Alford. I'm founder of a company called Engineering Design Group. We also like to call it EDG or EDGE. We've been in operation for about 2 years. We design hardware, mobile apps, web apps, and the entire cloud infrastructure in between. So, I'm here to talk to you guys about security and really happy for the opportunity.
Oh, yeah, we are more than happy that you're here. I think one of the sore points that Neil and I have actually not run into is that there is a huge hardware element for cybersecurity and zero trust in particular, but most people beyond the concept of devices, it's not even on the table. It's completely missed out of a lot of the frameworks. I think maybe they'll do light touches, but for most people, they probably consume it in cloud-driven elements, which obviously there's aspects of what you do, and we can kind of get into that in a minute. But I think you're going to be able to bring a flavor of this conversation that we just have not been able to reach yet. So this will definitely be highly enlightening, and I'm sure our folks at home are going to be thrilled to be able to kind of get that insight, especially for other startups and organizations who are trying to build in the hardware space and trying to meet with these current modern demands as well. Cool. Yeah, sorry, Neil. Go do your thing. I always interrupt you.
No, you're good. I was just going to say welcome aboard, Ryan. I usually let Elliot maybe preposition the room a little bit with the first question or two, and then we can take off and come back to him towards the end.
Yeah, there you go. I usually chime in with the stupid comments somewhere in there, but
No.
so I'm just joking.
He's smarter than he wants you to know. He just wants to keep you off guard until he really lays it on us both.
Might be the case. We'll see. So that being said, usually we do kind of throw out some basic questions, but I'd love some insight into what you're building today and where zero trust falls within that scope.
Yeah, so where we got really acquainted with zero trust was really when we started to work with bringing on employees and contractors and interns and that sort of thing. And we started talking about zero trust, and the concept of zero trust, as you guys know, is basically never trust, always verify. So on the company organization level, for us, that really meant limiting who has access to what, right? At a very minimal, whether it's passwords for our infrastructure, whether it's GitHub repositories for things we're building, and these sort of things. So the whole idea is if you bring on an employee or a team member or a contractor who's working on just one project, they don't need access to all of your projects. They don't need access to your entire code base. They probably don't need access to your networking infrastructure. They don't need access to all of your passwords. So that was really where we started to implement zero trust right from the get-go, using a password manager to help with all of this. And from there, it kind of just became one of the core elements to how we operate. And on the product side, we do develop hardware, software, cloud infrastructure. So there's a lot of pieces compared to some other tech organizations. A lot of organizations will just have maybe the mobile app will be their focus point, or maybe the cloud and databases will be their focus point, or they're just creating hardware. So we also really needed to think about this in how we're building our products. And we talked about the repositories and all of that, and limiting access. But when you start to have hardware accessing databases and users accessing databases, uh, there's also a level with the technology where you don't want to just trust your devices or trust your users. You need everything to authenticate. And really, what's interesting on the hardware side that I think is really important is treating the devices, IoT devices, as actual users. And once you start to look at them as users, um, it can really simplify the product design. It can simplify the organization, and the same types of zero trust concepts that you apply to users can also then be applied to those devices.
So you are speaking to the choir on this. I lived and breathed zero trust accessibility, and I've made a note to Neil about this quite a bit because obviously in the past there were things like putting a DMZ in place, which reduces some access, but most organizations still today rely on VPN access, and that as as much as certain companies will say, and they say that somehow it aligns with zero trust, it still involves a level of implicit trust that just gives too much. But yeah, without a doubt, obviously there's software defined perimeters or SDP. There's now zero trust network access or ZTNA. I'm just curious, and I love the contractor use case because that is always like the easiest entry point for having that conversation about granular access controls and giving just the right amount. Because obviously, if they only need access to one database or one resource, how are you looking at a situation like that where you only want to give them access like that? What are you trying to put in place to, I guess, prevent opening the or putting the moat down for the castle?
Well, a lot of times, if we are working with a contractor, it starts with um, really kind of that initial conversation with them where we're effectively interviewing the contractor that we want to hire for their capabilities. But if they're sitting down and telling us about their organization, um, usually usually groups that are mindful of security issues are going to bring those up uh, when you're hiring them, and they're going to be eager to tell you about all of the things they're doing to protect your repository, protect your data, not put app secrets in the repository, and those sort of things. And if they're not talking about that, for us, that's kind of become just the first red flag. And well, if they're not talking about it, you're going to ask them about it. Hey, what are you doing? What are you doing to prevent issues? Who's working on this? What is your vetting process for your team members and that sort of thing. And so it for us, it's actually felt like a pretty natural part of the process when we're vetting contractors. Now, I obviously all startups kind of do things differently, and we've had some really good luck with contractors, and we've had some experiences that were not ideal as well. And as we're growing as an organization, we're finding that it's actually better for numerous reasons to keep our technology under our roof, right? It eliminates that question of who's going to do what with our intellectual property. Um, you can sign as many agreements as you want, but if somebody's out there, if an employee of a contractor is fired and they have a copy of a repository on their laptop, well, what can you do, right? Unless the laptop is a company-owned laptop. Um, so by bringing technology into the company and taking it away from the contractors, you become a more secure organization, but there's also the benefit of that know-how is inside of your organization. So when issues come up, and they always do, you're not going to have to rely on the contractors to bail you out. So
So I'm going to personally backstep slightly on something you said a minute ago. I've got my handy dandy note taking devices so I can remember to ask certain things, like pique my mind and still pay attention. Uh, that being said, getting started, you mentioned, getting to a methodology around finally treating the devices as if they're a persona, right? More implicitly. We tend to put in a standard IT frame of reference, we tend to do a pretty decent job at a good org at saying, device A, talk to device B, and that's what it should be. Now, we don't necessarily do a good job monitoring when it starts talking to device C, however, right? When someone comes in and pivots through. But I think in control systems world, this is one, should happen a little bit more exclusively, and two, it's probably also a lot harder to do as people are still mapping old school OT to new school IoT concepts, right? So kind of curious in that frame of reference where you see a potential breakdown between 20-year-old tech stack and trying to make sure that something can't pivot through those doors versus modern tech stack that might be able to take advantage of more common practice sense stuff where there might actually be a legit IDS inside the control system, right? Or some version within the historian or some control groupings, right? For that implicit. So just kind of curious your take on old school versus new school and treating the device as a person in that rationale and making sure you don't completely crash something.
Yeah, that's a great question. Let me kind of start with the problem that we're trying to solve with our product, and we can kind of dig in from there.
Yeah.
And if I take a meandering path, just feel free to steer me. So our
Follow.
goal is really to allow our customers to monitor their data and own their data and get the raw data from any number of devices in the world that are connected to the internet, whether that be through Wi-Fi, cellular, or satellite technologies. Get that data to their fingertips in a reliable and secure fashion. So to do that, you know, it's very easy to have an app talk to a small handful of devices, right? But what tends to happen when companies are scaling up IoT, they're gonna start with a small number of devices at first to prove that you're the vendor that they want to work with. Okay, they may purchase 5 or 10 or 20. They're going to put those on a handful of networks, maybe one network, depending upon their application, and they're going to use a mobile app or a web app with a combination of users to access those devices. Once that initial deployment is successful, the hope is that company is going to grow, right? If they have a retrofit solution, if you're retrofitting a non-connected solution or some kind of a legacy solution, um, they're going to be quickly ramping up the number of devices that they're working with and the number of users. So when you go from just 5 or 25 devices to 100 or 500 or 1,000, there's a lot of special things that need to happen to be ready for that, right? Making sure that the channels are big enough for the data, making sure that multiple simultaneous accesses are not interrupting each other, right? So we achieve that with our cloud infrastructure. Okay, so in our platform, there's no way for a user to access a device or for a device to send data to the user without passing through our cloud infrastructure. So that's really where the API that we've developed that allows users to access data and that allows our devices to receive commands and submit data to the cloud. That API is really kind of the first level of protection and all of the encryption and tokens and verification that has to happen there for authentication. That's really the first level of protection. So back to your question, which I think was, how is this different than the old way of doing things? And my belief is, at least what I've seen in my in my career, which is, limited to my worldview, uh, historically, devices required a very large amount of configuration by the user, right? So the user had to know, how to set up IP addresses, how to set up ports, right? Default passwords, which we hate, right? Every device of this model number shipped with the same exact password, and now it shows up out on the internet, and that becomes an attack target for everybody today. So part of how we handle that is, um, as you guys know, reducing the surface area available for an attack. So um, what we try to do is make the best choice on behalf of the user. So all they have to do is plug in the device. We ship them the device. All they have to do is apply power, and they log into an app, and everything else in the background just magically happens, right? They're not going in there configuring passwords, setting up networks and this complicated stuff. So that to me is really something that can be done today, and we're starting to see more and more companies head in this direction, that I think is going to improve. When we look back in 10 years, we're going to say, you know what, this worked a lot better than the way we did things 20 years ago because there was less configuration.
I take my brain out into left field a lot. I used to do, loosely termed, exploitation and worked on like physical hardware security on embedded systems for all of like maybe a year and a half, 2 years. One of those things like, hey, who wants to go to Black Hat and learn how to poke and prod things with some diodes? I'm like, sure, send me. That being said, I love the concept of, especially with any device, any security device, the fundamental idea of geofencing something. If we think about it's a server and you've got it locked down the way you should, and there's zero trust mentality that only things from this region, this construct, all this, that first entry point, barrier to entry, unless they somehow manage to go through the backside, is always going to be from something not within your spectral area, right? Unless they happen to go to your house and actually go through your system, which is possible. I don't know. The idea with geofencing for IoT makes even more sense because most of these are some kind of cell phone enabled type device that inherently has a GPS chip somewhere in the solution.
And one thing that's really interesting about that comment, you're absolutely right. We're seeing more and more devices make it into rural applications, and we're still in this shift of everybody transitioning over to cellular. But on our side, so we're not just in the consumer space, we're also in a high reliability space. So
Yeah.
when you talk about high reliability, you start talking sometimes about defense contractors, sometimes about energy infrastructure. So thinking back to the Colonial Pipeline incident, right? You know, cellular devices are not going to be enough. So there's going to be cellular devices, but there's going to, pretty soon everybody's going to be phasing out cellular for satellite, right? And so there's going to continue to be a need for this geofencing, and um, you know, when we think about the all of the worry and scares of the transition to 5G and how is this going to work and what's going to be around, what's not going to be around anymore. Um, Nobody's really having that conversation of, well, how do we need to behave differently once everything's on these satellite networks, right? And
Yeah.
I think engineers, I see a lot of engineers that are really excited about these devices. I'm excited about them. I have some eval boards coming in that I'm really eager to play with, but I think we need to start looking at that and saying, wait a minute, this is something we need to look at and really consider what are the pros and cons of this service, because at the surface level, satellite sounds really good, but I think we need to pick it apart and analyze what are some possible consequences of going to satellite versus cellular for IoT.
Yeah, on that note, I mean, that's a wonderful point. it's kind of funny. The sooner we get tech now, obviously, the sooner we phase things out as things get exponentially growth, all some other stuff. On that note, from a SATCOM's perspective, I am happy to report that there is an ISAC out there that is very worried about this idea. The downside is here in the States, right? We don't yet consider space infrastructure oddly enough, a critical asset, key resource, critical infrastructure. Oddly enough, it's considered a supportive element to other things still to this day. But obviously, if you took down SATCOMs, you took down some kind of Earth station, something like that, there's so many things that are going to go away very, very quickly. Heaven forbid you just take out GPS on things, and that really mucks everything up, right? Especially at these remote stations that rely on that for tokenization and passing off timing. That being said, Space ISAC, just to plug someone that I'm very familiar with, highly encourage looking into that endeavor. And, if you have a really good personal preference into that side of the house and getting involved, as it seems like you might, hit them up. They're there in Colorado Springs.
Oh, wow.
And on a side note, I'm also happy to make intros into that world too. I love the ISACs and the ISAOs. It's one of my personal things that I like to work in and help do things with for collaboration, information sharing. But you're back on track. Your concerns about that are being directly echoed by this new community. So larger companies that are board members of this company have taken notice that the government seems to kind of push them off to the side. Now they're putting on this big major focus, and there's this huge growth effort over the last roughly now almost 2 years to build something around the satellite community, SATCOMs, infrastructure up there, everything from rocket launches, physical, all the way down to the data layer, digital and everything.
Well, one of the other things that this conversation brings to mind is when we got our our router. We started up the organization. We got a router. Had to get some equipment online, and I hadn't bought a router in like 10 years, and it has a backup for cellular. So if your Wi-Fi goes out, you can still have an internet connection to the office. And I think IoT devices, talking about the transition to satellite, it may not be a transition. It may be satellite with cellular backup, depending upon the location, right? And a lot of when we talk about IoT devices, a lot of IoT devices are being used for asset trackers or like fleet management. So these are things that are going in and out of regions that have coverage. And so, maybe there's some parallels there where depending upon, if you have the option for both cellular and satellite, what is more secure for that application and why, right? And what's going to keep the device connected in times of need versus which of those networks is more likely to have a hiccup for whatever reason.
Yeah, I think that's something else I always forget about the trucks with their GPS monitoring and location tracking, all those other fun things. That's a whole nother bailiwick of funness. And that throws geofencing potentially out the door for that particular asset, right? And they can have their laptop and everything running through whatever comm system they've got in there. And, they can drive from Cali to Alaska in 2 weeks, right? But when you think about concepts, for me, the need for zero trust from an IoT device, or pick a flavor of whatever it may be, an RTU, IED, whatever it is, those end units, that's where the end goal is a lot for some of the potential threat actors, is to get onto that end device to open up a switch or to close the switch, whatever they want to do. But at the end of the day, whether they're exposed to the internet or not, if you make sure it's talking to this device and only this device, and then to your product's point, this device inherently is also managed through another product solution to make sure all this is managed correctly, and that's the only trust line. And it's that consolidation of monitoring and effort, which in most OT networks doesn't really happen very well from what I've seen. Everything's just floating around out there. Maybe it's behind some kind of historian or MTU, whatever it may be, for the sake of the human in the loop. But once you're in there, you are literally in there in a lot of these networks. And I think that's what kind of freaks me out a little bit. You have to get there still, and that is thankfully still a very hard part of the puzzle.
And I think what you're talking about, I think what you may be alluding to here is, uh, hey, you go out in the field, you want to hack into some computer system. Oh, there's a USB port on it. I'm gonna plug into this, right? And so there's this is another element that's interesting on the hardware side is um, there's I'm going to group hardware into kind of two sets, okay? And there somebody else would yell at me for this, but there's two sets. There's what I would call COTS devices, commercial off the shelf, right? So that would be um, oh, we don't have time to design something. We're going to go buy this embedded x86 PC from this company because it has, the latest Intel Core processor that we need. It's rated for minus 40 to plus 85 Celsius operation. They've designed it as an off-the-shelf product. I can order it. It'll be here in 2 weeks, right? When you're buying a product like that, where you're putting on the operating system and you're developing the IoT hardware, all of the connections, the product is going to have a lot of peripheral connections available to it. It may have serial ports, parallel ports, probably not parallel unless you're like really, really old school legacy embedded stuff, Ethernet, USB, what have you. All of those things are going to be exposed. So when the user gets that product and puts their software on it, they can use it in whatever way they need. Well, there's going to be a limit. There's likely going to be a limit to what the user who's putting the software on it, what they can button down, right? It's going to be limited to the operating system and their software, whereas the vendor who's supplying that COTS product, if that's running, if that's like an actual embedded computer running a BIOS, that BIOS has the capability to really lock things down in a different way at a lower level that's going to completely turn off connectors and not expose them in the address space, for example, right? So we have this one category of devices, COTS devices, and that could include Raspberry Pis, Arduinos, anything where you get the product and everything's turned on. And then you also have this custom tailored world of hardware, and that also kind of enters EDG. We're kind of straddling that space now because we have created standard products, but we configure them uniquely to our customer applications. And what's really nice about that is we can turn off things fully at a lower level when they're not being used, right? And okay, yes, if somebody hijacks our firmware, can they turn it on? There's probably some way to do that that we haven't uncovered yet. But for instance, if we have a product that, if you had a product that uses Bluetooth for commissioning that device and connecting that device to a Wi-Fi network, is that Bluetooth on? Is it left on 24 hours a day? Or when they turn on the mobile app to punch in the password, does Bluetooth turn on only on an as-needed basis, and then the vendor turns it off? And so this is where I think the zero trust element really comes into play with customized hardware that is designed for a specific application, and that's where I think there's a difference. And part of the difference is you can buy the Raspberry Pi, you can buy the off-the-shelf embedded PC, and get up and running quickly, but you're not going to have the same level of security granularity that you would if you're designing a customized solution from the bottom up, or you're working with a vendor who's designing a custom solution for you from the bottom up.
So I say it's nice to know that in control systems, unique customizations and kind of DIYing it based off what you want is still a thing. Old school, when you get a Siemens product, pick a Step 7 product back in the day, no matter where you're at, I buy it, you buy it, and they buy it, and everybody's ladder logic and programming structure within it is all completely different, right? Security through obscurity. I think that's a 101 thing for most control systems. It's nice to know it's actually still a thing. I honestly think that's a good thing. I think unique customizations around certain aspects are inherent to what's needed, but also a good way to mitigate commonplace faults where, just because that there's a vulnerability and pick a Siemens, Sprecher, whatever product or whatever it may be nowadays. I'm a little behind on the brands that are out there, but doesn't mean you're going to actually use it on target A when you found it in target B, even if it's actually readily available, because hopefully they maybe turned it off. Anyway, that being said, when we start thinking about deployment operations and putting these devices, do you think from an IT to OT perspective nowadays, do you think it's based off of what that network is supposed to be doing? Do you think it's easier to do the right thing to lock down an OT world comparatively to an IT world from a zero trust mentality? At least at like the core end device. So coming back up to the top of that, where treat a device like a person perspective.
Right.
An endpoint device should really only ever probably really talk to one other thing, right? It maybe a couple, depending on the engineering, what kind of accesses they're going through. But it sounds like with y'all, the idea is to provide that central focal point for log management, perhaps, if I'm understanding right.
Right. Yeah. It's not just for log management. The log management is important for debugging purposes and for security purposes. The central point is, what can I say? How do I say this? It's the logical way to design a platform for distributed systems, and it comes with it lends itself to security in some ways. Right now, you have to design in various things. Right, it's not just going to be secure, but there is an inherent nature to security when you're using, when you're not allowing devices to interact with each other directly. But I think you're still going to have that. We haven't quite gotten into that area. We've had some customers that have asked us, where okay, we have this one device that needs to talk to these other things that are local to that device. I guess that would be in the realm of edge compute, right? But we haven't actually, our company hasn't actually implemented anything in that way yet.
Yeah.
So
I think the one concern I probably have with I don't know if Zigbee is still a thing or not. Maybe it is, but power infrastructure at the neighborhood level back in the day relied on, maybe it still does, Zigbee for the new meters and the lights and everything to really talk. But it's a full mesh topology kind of concept. But it was an implicit trust model. So if you could get into the system one way or another and understand what formatting they were using for traffic, you could get into the system and collect a lot of fun things.
Oh wow!
And it's inherent to any communication structure. It ran off of the same bandwidth as 802.11. I'm going to get it wrong. G, I think. I don't remember. But anyway, long and short, different protocol standard for comms. But there was this implicit trust when you set it out because it was supposed to be a closed network. But you stick up an antenna, and if you can take enough packet capture and understand what it is you're looking at, congratulations. Most of that stuff wasn't very well encrypted. Or if you get access to someone's meter, and by proxy, they can talk to any other meter on the network because they got to pass billing data down this mesh to eventually whoever's collecting it in the billing system. So I guess that's something that I'm thinking about from a worrisome perspective and it sounds like we're moving, at least from your realm of what you're working with, they're moving away from maybe the core competency of that loosely, hopefully, and moving towards more of like back to that centralized piece.
Yeah, it's hard to say. I think it's going to be application specific, and some of the areas that we're trying to get into right now, which are more in the oil and gas and energy space, we've recognized that there's already some IoT infrastructure in place, right? So when we're trying to solve one of their problems and we say, hey, we've got a product for that, there's going to be this push-pull of, well, we've already got our network. We want your device married to that because we already have this point that's communicating up to the cloud. And, again, it comes down to convenience, time, money, and, okay, what are the consequences of that? And is the owner of that application willing to live with those consequences, right? So we're going to have to deal with this pretty soon. We're going to be dealing with this year, some of these questions. If I may, there was something I wanted to talk about that kind of, I think also lends itself to zero trust. And there's always this trade-off of, how much data are we sending? What's it going to cost us, right? What's our monthly cost per device? And one thing that we've been noticing is, geez, our costs are higher than we thought they were going to be. And the reason that is as a small company, we've been segmenting our customers to use. We actually have we have unique instances of our infrastructure for each customer. And our philosophy behind that was, hey, if these are slightly different applications running on the same infrastructure, different data sets, different numbers of systems, if we have one customer's application goes down, if something were to happen, the other customers don't suffer, right? Those continue to run. But similarly, we've also done this for the security side, right? It keeps, if somehow somewhere someone were to get into our system or get onto one device, they're not going to be able to hijack our entire customer base, right? Because these things are segmented. Well, that has a higher cost to it, right? You're running more app instances. You have a lot more things to manage. So what we've started to look at, and what virtually every SaaS company does is there's different pricing tiers, right? So what we're going to be doing for our entry level tier is everybody's bundled in on the same system, right? And this is where I think from the user standpoint, what our experience is with customers is again, we want to buy a device. We want you to ship it to us. We're going to plug it in. We need to access it. If it works, it works. That's all we care about. Nobody is out there scrutinizing, hey, well, okay, what's the difference? What do we really get with your enterprise plan? And I think this comes back to, we're here to serve our customers, and that means steering them in the right direction that is best for them, even if they don't know that, right? And having those conversations and having those discovery conversations about what they're doing to really say, listen, we need you on this tier because your application is doing something very sensitive. It's going to cost you more money, but let us explain to you what's going to happen here that's different than this lower pricing tier, right? Again, from the hardware side, not trusting that our own hardware is secure. Somebody can and will hack into it. This happens to every company, and every company who says, our devices are 100% secure probably just doesn't understand security. You do everything you can. It's a defensive thing. You follow, you patch things, you send over their updates to your devices, you watch the news and you get the reports, and you plug the holes in the ship before they're holes, I guess, right? But inevitably, as we learned, I think 2 or 3 years ago in the x86 world, Spectre and Meltdown. I don't know if you guys if you heard those words in your circles, but what they uncovered that every x86 system going back like 20 years had these vulnerabilities, and the only way to patch it was with a BIOS update, right? Well, so how many of those systems are running clean water for municipalities today that don't have the BIOS update, right? So it's not so much the security. We're not so much worried about what's going to be exposed today, but the nature of IoT is, millions of devices getting put into the world every day, every week, and the growing number of devices. Well, um, what about the devices that just get put out into the world and then the company ceases to exist and there's no more updates, and customers, they have, you have all these consumers with these IoT door locks and IoT window locks, and one day they're just not going to be supported. So what? You just throw all that away, and you go install a bunch of new ones. So again, I think all I'm saying is that things there will become a time where the technologies of today will be able to be hacked. We're going to be at a different place 5 years from now, 10 years from now, and um, you know we need to do what we can as soon as we can to defend those devices.
Yeah, I think you incidentally opened my favorite can of worms, which is the concept and definition of zero trust. Because if you look at it, maybe from the vendor side, not as much, because I feel like they're being a little bit more intelligent about it now. But silver bullets, as far as security technology, definitely used to be a thing. But zero trust definitely gets put very high up on a pedestal as far as how secure that concept and following it to a T will basically enable you to prevent breaches and elements like that. So I fully appreciate the realist view, which is somehow, somewhere, internally, externally, there's going to be an entry point, regardless of the adoption of zero trust or specific technology elements such as that. But yeah,
There's a
that
there,
is
there was
yeah.
there was a sensor manufacturer a couple months ago that I was talking to. We were going to be evaluating their sensor, and we're putting it on our platform, but they had their own platform. And of course I asked, well, okay, what are you doing to secure your platform? And it was kind of just like, oh, don't worry, it's secure. And it's like, well, don't give me that. Okay, so what are you doing? Are you working with an external pen testing group to verify that? Can you send me a report? What are you doing? And um, I think there's there's always more that companies can be doing. And we are big. Okay, we're developers, we're engineers, we're big on testing, we're big on automated testing, but we're also big on cross testing and having other people, if one person writes the code, having somebody else on the team review the code, test it. But hiring external test parties and external penetration testers, I think there's so much value in that because they have their hands on other products. So their experiences are going to be not nearly as narrow-minded as the teams who are designing the product, where you have tunnel vision. You're just like, okay, we have to ship, we have to ship, we have to ship. And um, I think that's a very delicate balance that a young startup company has to deal with, is meeting deadlines, but also, is the product secure? And I don't think there's a right answer for what that balance is, but continuous improvement is something that all companies can and should be working towards.
Yeah, I think that's a wonderful point. And device security is a lot more than just making sure an IP address can't get to it. It's a lot more robust requirements around that. So, and the last little piece for me, you mentioned earlier on about, the physical access perspectives of this, right? So right down to the whole thing. If you don't have a robust security posture for physical, digital, and everything else that goes in between, just because I can't log on from IP address A, B, or C doesn't mean that I'm not going to find something else if it's still dangling out there on the internet's in front of other stuff, right? at some point in time, you will find that hole, you will get in, and there's a lot of other things that go into that mitigation strategy to make sure that that one hole is not as impactful downstream, for sure.
Yep.
Yeah, totally agree. And I think actually, Ryan, you and I kind of discussed this before. I know it's future state and basically prodding holes into what you do with pen testing and activity like that, but finding those proactive elements that really just allow you as your own worst enemy allows you to kind of crack open the system to the best that they can.
A couple other things that I just wanted to throw out there before we're done is, zero trust. It doesn't have to be an expensive thing for companies to implement. It's a cultural mindset, right? And I think once you have once your culture has adopted that mindset, it becomes baked into your daily habits and how you operate. But similarly, one last point I really wanted to talk about was vulnerability disclosure policies, VDPs, and this is something we encountered this within the last 6 months. I think the group is called the IoT Security Foundation, and I was talking with them, and I read this article. Oh, you need a VDP. And I was like, well, what is this? And so a vulnerability disclosure policy. This is another small shift you can make in your organization, and it's really coming up with a short, simple, easy to digest document that is public that tells your customers, here's how we handle security vulnerabilities, and it does a couple of things. So first, anyone who does find a bug, it gives them a dedicated channel to reach you, and but probably more importantly is it communicates, hey, we're not gonna point fingers at you if you find this bug. We're gonna need to look at it. It's gonna take us 48 hours. Then we're gonna respond to you, and it kind of, what you don't want is for somebody to find a bug and for some reason feel like they can't report that to you. You want to know about it, and so having some kind of a web contact form or an email dedicated to this with a public facing policy. It kind of says, hey, here's the type of company we are. We want to talk openly about this with you. We if you find something, we hope you'll talk to us about that. And I have not looked for any company that's had one of these, but I've never, what was the privacy policies, right? Suddenly in the last, all of a sudden, every company had a privacy policy, and you go to their webpage and it's boom, in your face privacy policy. Well, I hope there comes a time where for IoT companies, we're going to see, privacy policy, vulnerability disclosure policy, right? Because these are things that companies should be educated on. We should know that these exist. We should, put the link in the bottom of your webpage or wherever. Maybe it doesn't need to be a pop-up, but if you're in the business of IoT, you are in the business of security, whether you like it or not.
I love that take. I mean, what you basically hit on is building and establishing trust in a zero trust world. When you start a baseline at zero, how are you able to do that with customers and people that are connected to your devices and software? So being able to have that level of transparency and communication, that is not something that a lot of organizations are probably comfortable doing. So being forward thinking and kind of build that into your culture. I mean, the only thing that I could figure would be that is a step towards establishing trust. And again, just not a lot of organizations are comfortable with it.
We're a young company, we're small, and we hope to grow. And part of our strategy is really people aren't going to buy our stuff unless they know how we operate, right? And so educating customers on proper practices, whether those practices are security related or not, whether maybe it's, hey, here's how you want to wire your system to make sure that you're not getting noisy data, right? But educating your customer on these types of practices, it builds trust, like you said, and really, you know, we want to be there when somebody's comparing and contrasting companies. Hey, who are we going to buy this device from? We want them to say, well, we read that one article from EDG and they taught us about this particular feature and we really like that. We're going to buy from EDG, right? And so again, these are all they're tools to improve security, but they're also tools that will actually help move your company forward.
Day one, we did this the last call too. Day one, if you had to pick something on the zero trust concept to start off with, whether that's research, which everybody hopefully is looking to do that too, but whether it's learning or implementation focused, either side of the spectrum, what is day one for you, for people kind of just diving into this really about, or could be?
I would say low-hanging fruit, go down, implement a password manager and create, vaults or areas in that password manager that limit what users, what your team members can access. Restrict their passwords on an as-needed basis. If you're a small organization, that's a really quick thing to do, and it doesn't cost a lot of money. So that would be that. I think that's a great introduction to understand how zero trust works.
Excellent. Thank you so much for your insight. I appreciate that we were able to do a bit of a deep dive between the hardware and then some of the lighter touches, which is more friendly to my education. I'm just kidding. Again, just thank you so much for your insight. I think this has been incredibly interesting. A lot of people beyond the devices, just at the basic level and user touch points, don't really look at the concepts of zero trust involved. But I feel like as we kind of build this conversation, we'll be able to point to this conversation and be like, hey, this is exactly the kind of concepts that we need to look at, being fully transparent, taking into consideration policy and documentation and what elements that those are going to play in the future of zero trust. So thank you so much for being able to be part of that conversation.
Yeah. Ryan, thanks for putting up with my ignorant questions. Like I said, I have weird ones, but every once in a while they come back around to good things. So thank you for following along with me a little bit.
I certainly have some homework on some acronyms to do when I get out of here. So I really enjoyed talking with you, Neil and Elliot. Thanks for the opportunity to talk about zero trust and security in the IoT space. I had a lot of fun.
Excellent. Well, thank you all so much, and thank you for listening. We will see you all next time.
Thank you for joining AZT, an independent series. Your hosts have been Elliot Volkman and Neil Dennis. To learn more about Zero Trust, go to adoptingzerotrust.com, subscribe to our newsletter, or join our Slack community. Viewpoints expressed during the show do not reflect the brands, employers, or companies of our hosts, guests, or potential sponsors.